Hello, and welcome back. In this video, we'll be finding the cosine and sine of a radian measure by hand. What are the exact values of cosine pi over 4 and sine pi over 4? We begin by setting up a unit circle, and we sketch out the angle for pi over 4. Now in trigonometry, a straight angle, or 180-degree angle, is represented by pi. So I know that the measure of this straight angle is pi. And over here I'll put 0, so we move counterclockwise from 0 to pi. Now if I have pi over 4, that's equal to 1/4 pi. 1/4 of 180 degrees equals 45. So this is a 45-degree angle. To help us find the sine and cosine of a 45-45-90 triangle, or I'm sorry, a 45-degree angle, we need to form a 45-45-90 triangle. So here our angle is 45 degrees. We form one of our special right triangles that you may recall from geometry. So I bring a straight line down, which is perpendicular to the x-axis, forming a 90-degree angle. And since the sum of the angle measures of any triangle are 180 degrees, then 180 minus our right angle, 90, minus 45 equals 45. Okay, so this is our 45-45-90 triangle. 45-45-90 triangles have a special property, and that property is our hypotenuse can be represented as x times the square root of 2, and it has a relationship with the other two legs such that the other legs are both valued x, and they're congruent to one another. So for any 45-45-90 triangle, the hypotenuse can be represented as x times the square root of 2, and the other two legs are represented as x. Because we are working with what we call the unit circle, the radius is equal to 1. So that means that this segment right here is equal to 1 unit. R equals 1. Since R equals 1, we can use this information to find the values of each leg, x. So we'll set up our equation. We'll say 1 for the radius equals x times the square root of 2, and we'll solve for x. We divide both sides by the square root of 2. That gives us 1 over the square root of 2 equals x. But of course, we don't typically like to leave radicals in the denominator, so we want to rationalize. That means that I'll be multiplying the numerator and denominator of 1 over square root of 2 by square root of 2. Square root of 2 times 1 equals square root of 2. Square root of 2 times itself cancels out the radical, and that gives us 2, which is equal to x. So now I know that the value of x is equal to square root 2 over 2. This means that our length along the x-axis is equal to square root 2 over 2, and cosine corresponds with our x-coordinate of a point. So we can say cosine pi over 4 equals square root 2 over 2. Now sine corresponds to the y-coordinate. So here, moving up along y, is also square root 2 over 2 units. So sine of pi over 4 equals square root 2 over 2. right here at this point, when we move right, square root 2 over 2, and we move up, square root 2 over 2, that gives us our ordered pair, square root 2 over 2, square root 2 over 2, where the x-coordinate corresponds to cosine, and the y-coordinate corresponds to sine pi over 4. This concludes our example. I hope you found it helpful, and we'll see you next time.